Did you know a robot can perfectly flip a pancake and still be considered a failure? It sounds crazy, but it's true. Scientists are demanding more from their robot learners. Simply completing a task isn't enough anymore. Hit that subscribe button because today we're going deep into how researchers are measuring robot progress beyond a simple pass or fail.
It's a fascinating shift. We're moving beyond asking, did the robot work, and diving into the how and why of its performance.
Okay, so let's unpack this. Why is this so important? What's wrong with just looking at whether a robot succeeds or fails at a task?
Well, imagine you have a home robot helping with chores. It manages to fold your laundry, but knocks over a lamp and nearly trips over your dog in the process. Technically, it succeeded, but would you trust that robot in your home?
Definitely not. It sounds like a disaster waiting to happen.
Exactly. That's why relying solely on success rate is becoming a problem, especially as robots start to take on more complex tasks in real-world environments.
So how are researchers tackling this problem? How do you go beyond just checking a box to say yes or no when evaluating a robot?
One approach is using detailed rubrics. Think of it like a figure skating competition. Judges don't just look at whether a skater landed a jump. They consider things like artistry, technique, and execution. Similarly, rubrics for robots assess not only task completion, but also the how of it. Did it bump into things? Did it take unnecessary steps? Was the movement smooth?
So it's like grading a student on both the answer and the process they used to get there. But how do you evaluate a robot's movements over time? Their actions are continuous, not just a series of discrete steps.
That's where signal temporal logic, or STL, comes in. It's a powerful tool that lets researchers specify and automatically check for complex behaviors over time. For instance, you could specify that the robot should only grasp the object when its hand is close to the table.
So it's like setting up a series of checkpoints for the robot's behavior, making sure it's not just reaching the end goal, but doing so in a safe and controlled manner.
Precisely. And speaking of control, another important area is measuring the smoothness of a robot's movements.
So this is where our pancake flipping robot might fail, even if it manages to get that pancake in the air, right?
Exactly. If the robot is shaking the pan violently, that's a problem, even if the pancake technically flips. Smoothness isn't just about aesthetics. It's crucial for safety and efficiency. A jerky robot is more likely to damage objects or even injure someone.
Okay, so we've got these rubrics looking at the steps, STL checking the behavior over time, and smoothness metrics judging, well, smoothness. It seems like researchers are getting a much more complete picture of how a robot is performing, but are there any other tools they're using?
Absolutely. One more critical approach is Bayesian analysis. It's a statistical method that helps us determine if one robot policy is genuinely better than another, even when their success rates look similar.
Can you give us an example of how that might work in practice?
Imagine you have two robots, both tasked with picking up a specific object. Both robots successfully pick up the object 9 out of 10 times, but one robot was tested 10 times and the other was tested 100 times. Which result would you be more confident in?
I'd definitely be more confident in the robot that was tested 100 times. More data usually means a more reliable result.
Exactly. Bayesian analysis takes this into account. It considers the amount of data we have, not just the success rate, to provide a more nuanced and reliable evaluation of a robot's performance.
It sounds like this Bayesian analysis could be a real game changer, especially when comparing different robot designs or learning algorithms. We wouldn't want to jump to conclusions based on limited data. But speaking of learning from experience, I'm curious about how researchers approach analyzing robot failures. Isn't that an important part of the learning process?
You're absolutely right. Failure analysis is crucial. By carefully examining how robots fail, researchers can uncover valuable insights.
That's really interesting. It sounds like there's a lot we can learn from mistakes, even in the world of robotics.
Absolutely. Think of it like this. One robot might consistently fail to grasp an object because its gripper is the wrong shape. Another might succeed at grasping but then misplace the object because its navigation system is faulty. These distinct failure modes can guide future research and development.
So it's not just about whether the robot succeeded or failed.
Yeah.
It's about understanding the specific reasons why it failed, so we can address those issues and improve the design.
Precisely. Even in failure, there's a wealth of information to be gleaned. It's like a detective analyzing clues at a crime scene. The how of the failure can point to the why and ultimately lead to a solution. Sometimes those failures can be even more revealing than the successes.
So we've covered a lot of ground here. We've explored how researchers are moving beyond simple success rate to get a much more detailed and nuanced understanding of robot performance. From rubrics and STL to smoothness metrics and Bayesian analysis, it seems like the toolkit for evaluating robots is becoming increasingly sophisticated. But before we move on, can you give our listeners a quick recap of the key takeaways so far?
Certainly. Here are the key points to remember. First, relying solely on success rate is like judging a book by its cover. It's a starting point, but doesn't tell the whole story. We need to delve deeper into the how and why of a robot's performance.
Okay, so it's about looking beyond the surface. What else?
Second, researchers are using a variety of tools to get a more complete picture of robot performance. These tools include rubrics to assess the process, signal temporal logic to examine behavior over time, and smoothness metrics to evaluate the quality of movement.
And let's not forget about the importance of Bayesian analysis, which helps us assess the reliability of our results, especially when we're dealing with limited data. And as we just discussed, even failures can be incredibly valuable, providing insights into a robot's limitations and guiding future research. But I'm sure our listeners are eager to know how these new evaluation methods are being applied in the real world. What kind of impact are they having on the development of robots that can operate effectively in our homes, workplaces, and communities?
That's a great question, and one that deserves its own deep dive. In part 2 of this episode, we'll explore the real-world applications of these advanced evaluation methods and how they're shaping the future of robotics. Stay tuned.
Welcome back to our deep dive into the world of robot evaluation.
Glad to be back.
We've been talking about how scientists are going beyond simple success rates to really understand how robots are performing and why that matters. Now I'm really curious to hear how all of this translates into real-world applications. What difference does it make when robots are actually out there interacting with the world, not just in a lab setting?
That's a crucial point. A robot's success isn't just about completing a task in isolation. It's about how it interacts with its environment and, importantly, with us humans.
Right, because a robot operating in a factory is one thing, but a robot in my home is a whole different ballgame. I'd want it to be a lot more aware of its surroundings and how its actions might affect people.
Exactly. Take, for instance, a robot designed to assist with elderly care. Its primary function might be fetching objects or providing reminders, but the way it interacts with the individual is just as important. A robot that understands human behavior, moves smoothly and predictably, and even adapts to individual preferences will be far more successful than one that's just focused on ticking boxes.
That makes a lot of sense.
Yeah.
So those rubrics we talked about in part 1, where you assess not just if the robot did the task, but how it did it, those become even more important in these real-world scenarios.
Absolutely. And the same goes for those smoothness metrics. You wouldn't want a robot assisting someone with mobility issues to be jerky or unpredictable in its movements. It could be dangerous.
Definitely not. It seems like safety is a huge factor here. And speaking of safety, I'm thinking back to that signal temporal logic, or STL, that we discussed. How does that play out in real-world applications where safety is paramount?
STL is incredibly valuable for ensuring safety, especially in autonomous systems like self-driving cars. Imagine you want to make absolutely sure that a self-driving car never crosses a solid lane marker. You can actually use STL to specify that rule formally and then test that the car's software always adheres to it.
Wow, so it's not just a theoretical concept. It has real practical implications for keeping people safe in situations where robots are making decisions.
Precisely. And it's not just about safety. STL can be used to ensure a robot follows any number of rules or protocols, making it much more reliable and trustworthy in real-world settings.
Okay, so it seems like these more sophisticated evaluation methods are crucial for developing robots that can function smoothly and safely in human-centric environments. But I'm also curious about the impact on the research side of things. How are these methods changing the way scientists are actually developing and improving robots?
Well, they're providing much richer feedback, which allows researchers to understand a robot's strengths and weaknesses in much greater detail. Instead of just seeing a binary success or failure, they get a granular view of how the robot is learning and where it's struggling. It's like having a microscope to examine the learning process itself.
That's a great analogy. So it's not just about training robots to do a task. It's about understanding how they're learning and using that knowledge to refine the algorithms and improve their performance in a more targeted way.
Exactly. By analyzing those detailed rubrics, the STL specifications, the smoothness metrics, and even those failure modes, researchers can pinpoint areas where the robot's policy needs adjustment. This leads to faster progress and more effective robot learning overall.
This is fascinating. It seems like we're moving from simply teaching robots to do things to really understanding how they learn and evolve. And that feels like a huge step towards developing truly intelligent machines.
It really is. And remember Bayesian analysis. It also comes into play here, helping researchers assess the reliability of their results and make more informed decisions about which approaches are truly effective. It's about being more rigorous and scientific in our approach to robot learning.
Okay, so we've talked a lot about the benefits of these more nuanced evaluation methods, both for developing better robots and for ensuring they can function safely and effectively in real-world environments. But what about the average person? How can we, as consumers of information about robotics, know what to believe? It's easy to get caught up in the hype when you see a robot doing something amazing in a demo video.
That's a really important point. And it can be difficult to separate the hype from reality. One thing to watch out for is when the evaluation is solely focused on success rates in very controlled environments. While those demonstrations can be impressive, they don't necessarily mean the robot will perform the same way in a more complex, unpredictable, real-world scenario.
So it's kind of like judging a basketball player based on their performance in practice. They might sink every free throw, but that doesn't guarantee they'll perform the same way under pressure in a real game.
Precisely. Another red flag is a lack of transparency about the evaluation methods used. If a claim about a robot's capabilities isn't backed by rigorous and transparent evaluation, it's wise to be skeptical.
So essentially, we should be looking for evidence of nuanced evaluation, detailed analysis of those failure modes we talked about, and a clear understanding of the limitations of the robot's performance. It's about looking beyond the headlines and asking those critical questions.
Absolutely. And remember, a robot that excels in a lab setting might struggle in the dynamic and unpredictable nature of the real world. So don't be afraid to dig deeper and really understand how a robot was tested and how its capabilities might translate to the real-world applications that matter to you.
This has been incredibly insightful. I feel like I have a much better grasp on how to evaluate those claims about amazing new robots that we see all the time. But now I'm worrying about the bigger picture. All of this progress in robotics is bound to have a significant impact on society, especially when it comes to jobs and the future of work. What are your thoughts on that?
Ah, yes, the big question, and a complex one for sure. And that's exactly what we'll be tackling in the final part of this episode. We'll explore those potential societal and economic implications of these advancements in robotics, and how we can prepare for a future where humans and robots might be working side by side. Stay with us.
Welcome back to The Deep Dive. We've been exploring this fascinating world of robot evaluation, moving beyond those simple success rates, and really getting into how researchers are measuring robot performance. And last time, we left off with a pretty big question. How is all of this going to impact the future of work?
Yeah, it's a question on everyone's mind these days, and for good reason.
Yeah.
I mean, as robots become more sophisticated, more capable, it's natural to wonder what it means for us, for our jobs, our livelihoods.
Absolutely. I think there's a lot of anxiety out there, about robots taking over jobs that humans have always done.
It's a valid concern. But it's important to remember that history shows us that while technological advancements often lead to shifts in the job market rather than just eliminating jobs altogether. Think about the invention of the automobile. It displaced horse-drawn carriage drivers, but it also created a whole new industry, automotive manufacturing and repair.
So you're saying that while some jobs might become automated, new jobs will likely emerge in areas, related to robotics.
Exactly. We might see a rise in demand for, let's say, robot designers, maintenance technicians, trainers, and even specialists in areas like robot ethics and human-robot interaction. Just like we have software developers and cybersecurity experts today, we might have robot ethicists or human-robot interaction specialists in the future.
That's a really interesting way to think about it. Instead of a future where robots just take our jobs, we might be looking at a future where they collaborate with us, creating new possibilities and enhancing our own capabilities. It's a bit like how computers have revolutionized so many industries. We haven't eliminated jobs, we've changed them and created new ones.
Right. There's a whole field of research focused on human-robot collaboration, exploring how robots can, augment human skills and help us with tasks that are dangerous, repetitive, or physically demanding. Think about advancements in surgical robotics. Surgeons can now perform incredibly precise procedures with the assistance of robotic arms. It's not about replacing the surgeon, it's about making them even more effective.
That's a great example, and it makes me think back to all those evaluation methods we've been discussing. If robots are going to be working alongside humans, it's even more critical that they can be evaluated not just for their ability to complete tasks, but also for how they interact with people and their environment.
I couldn't agree more. Those rubrics, the smoothness metrics, even the signal temporal logic we discussed, they all play a vital role in ensuring that robots can integrate safely and effectively into human-centered environments.
So understanding how to evaluate robots isn't just an academic exercise, right? It's essential for shaping a future where humans and robots can work together harmoniously.
Absolutely. As we move towards this collaborative future, it's crucial to focus on equipping the workforce with the skills and knowledge to thrive in a, let's say, a robot-enhanced world.
That makes a lot of sense. So looking ahead, what kind of skills do you think will be most valuable in this new job market?
Well, technical skills will definitely be important, things like programming, data analysis, artificial intelligence. But what we call soft skills will be equally critical, things like critical thinking, problem solving, creativity, and adaptability. These are uniquely human skills that are difficult to replicate in machines.
It's encouraging to know that our own ingenuity and adaptability will be our greatest assets as we navigate this technological evolution. It's not about being replaced by robots. It's about learning to work with them and leverage their strengths to our advantage.
Exactly. The future of work isn't humans versus robots. It's humans with robots. And the key to success lies in embracing lifelong learning, fostering collaboration, and adapting to the ever-changing landscape of technology and innovation.
This has been an incredible deep dive, and I feel like I've learned so much about this complex and rapidly evolving field. It's clear that the future of robotics is going to have a profound impact on our lives, and it's important that we approach this with both curiosity and a critical eye.
I completely agree. We need to be asking those tough questions, not just about what robots can do, but also about how they should do it and what implications their actions might have on society as a whole.
As we wrap up this episode, I want to leave our listeners with one final thought. The future of robotics, and indeed the future of work, isn't predetermined. It's something we actively shape through our choices, our investments, and our commitment to building a future that benefits all of humanity.
Well said. The next time you encounter a robot, don't just ask, did it work? Ask, how did it work? And what are the broader implications of its success? Those are the questions that will help us navigate this exciting and uncharted territory.
Thank you for joining us on this deep dive into the world of robot learning evaluation and its impact on the future. We hope this episode has given you some food for thought and perhaps even sparked some inspiration. Until next time, keep learning, keep questioning, and keep pushing the boundaries of what's possible.